Dear students, as I told you in the last class, the tool of econometric analysis is regression. Regression analysis. Even though the term was introduced by Francis Galton to examine why there is stability in the distribution of the height of the population, it is used in a different sense in modern times. So let me give you the modern interpretation of regression analysis. The meaning of regression analysis is something like this. Regression analysis is concerned with estimating and or predicting the conditional mean values of the dependent variable on the basis of the known values of the independent variable or variables. That is the modern interpretation of regression analysis. Regression analysis is concerned with estimating and predicting the conditional mean value of the dependent variable on the basis of the known values of the independent variables. So the purpose of econometrics is to estimate and also to predict the conditional mean values of the dependent variable y on the basis of known values of the independent variable or variables x. To understand the terminology of regression analysis, we consider a simple example. This example is taken from Basic Econometrics by Damodar Gujarati. There are various ways in which regression analysis can be introduced, but this is perhaps the most simple method to introduce regression analysis. Now, suppose that in a certain community, village, there are 60 families. 60 families. Suppose also that these families can be divided into 10 income groups on the basis of monthly income. We divide these families into 10 income groups on the basis of monthly income. Now, income may be given in dollar terms or in rupee terms, whatever it is. Now suppose that these income groups are like this. Starting with 80, 100, 120, 140 to 60. Suppose the 10 income groups are 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. 10 income groups. Now suppose that in the first income group, so this is X. In the first income groups, there are 5 families with the consumptions given by 55, 60, 65, 70, 75. And also suppose that in the next income group 100, consumption vary between 65 to 88. In the third, 79 to 98. And the remaining income groups and the distribution of consumption is something like this. Something like this. Now, as I told you earlier, even if you have 5 families, 6 families, 10 families, 100 families with the same level of income, their consumption expenditures will not be same. This is because consumption depends, among other things, on many variables in addition to income, like wealth of the family, number of family members, and so many other factors. That is why you observe variation in consumption between families. Now suppose that we calculate the average consumption of families with a monthly income equal to 80. We simply add together these numbers, divide it with 5, because it is assumed that in the first income group there are 5 families. Now this quantity is written as expected y given x. Expected y given x. That is the conditional expectation of y given that x is equal to 80, x is equal to 100, x is equal to 120, x is equal to 140, etc. Now in the first income group, this expected y given x is 65. In the next income group, it is 77. Then it is 89 and etc. So we have expected y given x 65, 77, 89 and other values are there. Now if you ask a question, what is the expected value of y? Expected value of y, expected y simply. The answer is, we add together the consumption expenditures of all the 60 families and divide this with the number 60. That will give you expected y, and this is only a single number. Say for example, expected y for the entire family is 120. This is a single number. But if I ask a question, what is expected y given x? It is conditional expectation of y given that x is equal to 80, 65, x is equal to 100, 77, x is equal to 120, 89, etc. Now, let us assume that we plot this information in the form of a graph. We plot this information in the form of a graph. If we plot this information in the form of a graph, let us see what we will obtain. As usual, we take x on the x-axis, y on the y-axis. Now, when income is 80, we have 5 families with the consumption ranging from 55, 60, 65, 70, 75, etc. When income is 100, we have consumption expenditures ranging from 65, 88. When income is 120, again we have distribution of y like this. Now, when income is equal to 80, expected y given x is equal to 65. This is the value. When income is equal to 100, expected y given x is 77. This is the number. In the third case, this is the number. Now suppose that we join together these points with a line. We join together these points with a line. We will get what is known as the conditional mean values of y given x is equal to 80, x is equal to 100, x is equal to 120, like that. So we call these mean values the conditional expected values. Conditional expected values. We call these values the conditional expected values. Symbolically, expected y given x. Expected y given x. The conditional expected values. And conditional expected values, as I told you, is different from unconditional expected values. Unconditional expected values, there is only one value, that is the mean of or the average consumption of all the families. Conditional expected values are expected values conditional on x is equal to 80, 100, 120, 140, like that. So conditional expected values are different from unconditional expected values. Now, so in this graph, when income is equal to 80, the conditional expected value is 65. When income is equal to 100, it is 77, etc. When income is equal to 120, another value say 89, like that. Now, as we will see later, corresponding to each x, we have a distribution for y. In this example, there are only 5 families, 6 families, 7 families, etc. because the population is very small. But in the real world, there will be an infinite number of y values corresponding to each level of x. Corresponding to each level of x. When we join together these conditional mean values with a line, a curve, a straight line or a curve, we will get what is known as the population regression line. Population regression line. In short, we call it PR line, population regression line. Expected y given x is known as the population regression line. So a population regression line is nothing but a line passing through the conditional mean values of the dependent variable y. So geometrically, a population regression line is simply the line joining together the conditional mean values of y given x is equal to x1, x2, x3, etc., etc. And in econometrics, our concern is the estimation of this population regression line. That is, our concern is the estimation of expected y given x. Expected y given x. Now it is clear that, as it is clear from this graph, this expected y given x is a function of x. Expected y given x is equal to xi is a function of xi. Expected y given xi is a function of xi. Now, this equation, expected y given xi is a function of xi, is known as the conditional expectation function. Conditional expectation function, CEF, the population regression function, PRF, or the population, or simply population regression. We call this population regression function, or the population regression in symbol. Population regression, conditional expectation function, population regression function, or simply population regression. So a population regression function or a population regression passes through the conditional mean values of the dependent variable y. Now a question is, if expected y given xi is a function of xi, what is the functional form? What is the nature of relationship between expected y given xi and xi? This is an empirical question. In some cases, economic theory will tell us the nature of the functional relationship. In some cases, if economic theory is not very strong about the nature of functional relationship, we plot the observation on an XY scale and try to make inference about the functional relationship. Anyway, as a first approximation, we assume that expected y given xi is linearly related to xi. So we write expected y given xi as equal to beta 1 plus beta 2 xi. We write it as expected y given xi is equal to beta 1 plus beta 2 xi. That is, the conditional mean value of y given xi is linearly related to xi. And beta 1 and beta 2 are known as regression coefficients. Regression coefficients. Beta 1 and beta 2 are known as regression coefficients. Regression coefficients. And beta 1 is the intercept coefficient, beta 2 being the slope coefficient. And in econometrics, this equation, that is expected y given xi is equal to beta 1 plus beta 2 xi, is known as the linear population regression function. Linear population regression function, or simply PRF, population regression function, represented by the equation expected y given xi is equal to beta 1 plus beta 2 xi. Beta 1 plus beta 2 xi. In econometrics, our concern is estimation of beta 1 and beta 2. And in the beginning, I told you that regression analysis is concerned with estimating and also predicting the conditional mean values of the dependent variable on the basis of known values, known in repeated samples, that is a point which we will see later, known values of the independent variable x. It is clear from this equation that if we estimate the values of beta 1 and beta 2 by substituting the values of x equal to 80, 100, 120, etc., we can calculate expected y given xi. And that is the objective of econometric analysis. Estimation of expected y given xi equal to beta 1 plus beta 2 xi. And this is the concern of econometrics. And as I told you, corresponding to each level of x, there is a distribution for y. And for the time being, you need not worry about the shape of the distribution. That we will discuss in detail in a later class. For the time being, just think that corresponding to each x, we have a large number of y values. Naturally, we can think about a distribution for y. And the reason why, or the nature of this distribution, its particular shape, will be discussed in a later class. And this is what is known as population regression line. The line passing through the conditional mean values of y given x. And remember this, in econometrics, our only concern is the estimation of this population regression function. And as it is clear from this analysis, if the entire population is available to you, you can easily calculate the conditional mean values of y corresponding to each level of x. You join together these points with a line, you have the PRF. You have the PRF. The problem is, you will never know the population. In any case, you will have only a sample. So you have to use this sample to make inferences about the population regression function of the parameters beta 1 and beta 2. That will take us to the field of sample regression function.